Hi, so welcome back, and this will be my third lecture, second one on first chapter, origin of soil and its properties, and the next subtopic is soil as three-phase system. All right, now what do you mean by this three-phase system? Okay, in this figure, what you can see, this is a single element of naturally occurring soil mass. Okay, so what do you have in this element? If you take any small amount of soil from your plot, what all things you will get? You will get the soil particles, right? Solid. Then you will get, if it is waterlogged, if it has some amount of water content, then you will also get water in its void spaces. So let's say if I take 1 cup of soil mass, majority of the volume will be occupied by the particles, correct? Then a little bit of the volume will be occupied by water. Now apart from solids and water, there will also be air entrapped in between the different void spaces. Now all this has been pictorially represented over here. So this particular diagram is called phase diagram. Okay, so what can you see in this phase diagram? There are solids, there is water and air. Volume of solids will be represented as V suffix S. Volume of water will be represented as V suffix W, and air will be represented as VA. VA plus VW plus VS total will give me volume of soil element. VA plus VW, what will this give me? Volume of voids. Okay. Now the same thing can also be represented in terms of weights. Okay. So weight of solids will be represented as WD. D actually stands for dry weight. Okay. Now why do we call it dry weight? Because water we are considering separately. Okay, so that's why this weight of solids is exclusive of weight of water. So this is called dry weight, WD. Then WW will be weight of water and WA will be weight of air, which is equal to 0. So total weight of voids, V stands for voids, will be equal to weight of water because WA is 0. It's WV is equal to WW plus WA, but WA is 0, so WV, total weight of voids, will be equal to total weight of water in voids. Moving to the next slide, whatever I just spoke is again written here. It's the same thing that is written here. Volume of voids will be equal to volume of air in voids plus volume of water in voids, and total weight of the moist sample will be weight of water plus dry weight of solid. Okay, going ahead with the presentation, the next topic is soil properties, and these are the properties that we are going to evaluate in depth. Water content, unit weight of soil, density, specific gravity, voids ratio, porosity, degree of saturation, unit weight, index, relative unit weight. Now all these properties we are going to understand, also try to understand what are the relations, how they are interlinked with each other, right? So the first property and one of the most important properties is water content. Okay, if you all remember, when you all studied bricks or building construction or maybe even concrete, you will realize that strength of those building materials get very badly hampered with moisture content, right? Same thing happens with soil also. Presence of water in any soil alters its properties, its cohesion, its friction. Cohesion and friction, the moment these get affected, then naturally the strength of the soil will also get affected. The weight of the soil mass changes the moment there is water in the voids. What will happen? Obviously, earlier, if there is a soil mass without water, it will weigh much less. The moment there is water entering the voids, its weight increases. If you have noticed, a lot of landslides and all occur in monsoon. Why is that happening? The soil mass was otherwise very much stable on that slope, but the moment water has gone inside, it has become heavy, and now it has no other options. Obviously, there are other reasons also which trigger landslides, but yes, water, the moment it enters into soil mass, it becomes more vulnerable to this kind of damages. Water content is given by weight of water divided by dry weight of soil particles. So how do you get weight of water is practically how this weight of water is determined is usually we take few spoons of soil sample. So around 20 to 30 gram of soil is weighed with water, then it is kept for oven drying, okay, for 24 hours at 105 to 110 degree Celsius, and after 24 hours, once it dries in the oven, it is taken out and weighed again. Now that weight will be WD. Now initial weight and dry weight, we find out the difference divided by dry weight in percentage will give you water content. It is written as small w. This may look like capital W, but the font is slightly misleading. This is small w. So when you are making notes, please write water content as small w. Capital W in your notes should reflect as the weight. Okay, small w will be the percentage moisture content. Okay, capital W will be the weights. Okay, please note these things and please write down your own notes. Eventually, I'm only going to share these lectures. Okay, PowerPoint presentations, let's see, because what happens when I share PowerPoint presentation, you people consider those are the notes. PowerPoint presentations are just for me to aid me, to help me in delivering the lecture. Okay, so the next property is density of the soil, designated as rho, the Greek alphabet rho. So from our previous years, we know what is density, mass upon volume. What are the units? Grams per cc, grams per centimeter cube. Also, it can be written as kilograms per meter cube. Now, density can be of 5 different types: bulk density, dry density, density of solids, saturated density, and submerged density. Okay, there's a mistake here. This is not submerged unit weight, this is submerged density. Alright, so what is bulk density? If you go to the plot and you want to find out what is the density of the soil that is available in your plot, what you will do, you will take a sample of that soil. Maybe you will take a core, okay, and hammer that core. Core is nothing but, you can imagine, a small hollow section, a kind of a small cut section of a pipe. The diameter is usually around 10 centimeters, and the height of that pipe will be around 13 centimeters. So visualize something like this. So that hollow pipe section is hammered into your soil, and that's once the soil is what do you say, filling that particular core, then you remove that core out and bring it to the lab. Volume of soil will be equal to volume of that pipe. Okay, so height into area, and then what you do, mass upon this volume will give you the density. Next is dry density. Okay, dry density is given as rho d. Rho d is given as dry mass divided by volume. So you take the same mass, put it in oven, and then that mass divided by volume will give you the dry density. Density of solids will be the same dry mass divided by, you're not dividing it by the total volume of soil, you're dividing by the volume of only solids. Okay, so you're not going to consider the volume occupied by voids, you're only going to consider the volume occupied by solids, right? Next is saturated density. Now what do you mean by saturated? When water starts entering the voids, the soil sample starts getting saturated. So it may be partially saturated or it may be fully saturated, but the density corresponding to that percentage saturation of moisture will be msat upon V. So this sat this D, this S, this is in suffix. Okay, this is not directly written on the same line, supposed to be written little below. So just excuse my typographicals because I've imported this file into Keynote. These changes are happening. Alright, the next is submerged density. This is not unit weight, this is density. Okay, submerged density is designated as rho dash. Now, what is rho dash is when you have water entering the voids in soil particles, it starts getting saturated. At one point of time, all the voids will be occupied by water, in which case it is called completely saturated or 100% saturated. Now, what happens if you add more water? Already all the voids are filled with water, so when you add more water, the water will start surfacing. It will come above the soil. It is as good as the soil mass being sunk inside the water. Now this is a very dangerous situation. Okay, in such case the weight of the soil is going to decrease, right? And it is going to be reflected in its density as well. So submerged density rho dash will be given as rho sat minus rho w. Now what is rho sat? It is the saturated density, and rho w is density of water as 1000 kg per meter cube. So if suppose the saturated density is somewhere around 2100, you are deducting 1000 of density of water. So your submerged density will become just 1100. From 2100 it will go to 1100, that is nearly half. So this is a very dangerous situation, dangerous condition. Okay, so in assessing a lot of strength parameters, we have to be cautious when any material, soil material is given for testing. We have to be cautious that under no condition that soil is going to be in this submerged condition. Okay, so we'll stop here and we'll continue with the next properties in the next lecture. Now before that, there is one homework for you. You need to tell me, how do we find out what is mass of the soil? How do we measure it in the lab? Okay, how do we do it physically? Which instrument are we going to use? Okay, volume we know, maybe measuring cylinders or something, but how do we find out mass? Okay, with this I leave you all here. We'll meet in the next lecture.